Hi class, this is course 2, lesson 36, and today we're going to talk about ratio and sample space. And again, you do not need to write these objectives down, but this is what we're going to discuss today. We're going to write a ratio in 4 different ways. We're going to name the 3 numbers in a ratio, and we are going to identify the sample space of an event. We can write a ratio in 4 different ways. Ratio, vocabulary word here, you want to make sure that you understand what this term means. It describes a relationship between 2 numbers, and we can express it as 4 different ways here. We can use the word 2, we can use a fraction, we can write it as a decimal number or with a colon. And we are always going to reduce, but not to a mixed number. We will never write ratios as mixed numbers. And the numbers are always in the order given in the problem. So make sure that you understand what they are asking you for so that you write them correctly, and I'll explain here in just a minute. Here's an example. A class has 8 boys and 16 girls. What is the ratio of boys to girls? Okay, so the numbers, you're going to write the numbers in the ratio in the order that they give to you in the problem, or the order that they want. Okay, so for example here we wanted the ratio of boys to girls. So we know that we have 8 boys and 16 girls. So we would have a ratio of 8 to 16. Now you have to look at these 2 numbers, and if you can reduce them, you have to. So they have a factor of 8 in common, so this would be 1 to 2. Now I'm going to change this box up here, and we're going to see how this looks using the word 2, using as a fraction, as a decimal number, and with a colon. So these are all acceptable ways to write a ratio. What you want to do is start using ratios as fractions, because that's how we're going to use them the most. So if you can get in the habit of using fractions, that would be great. Just remember to always reduce, but never to a mixed number. Improper fractions are okay with ratios. Now we need to name the 3 numbers in a ratio. A class has 8 boys and 16 girls. What are the 3 numbers in this ratio? Okay, so we have 8 boys, 16 girls. There are 8 boys, there are 16 girls, and what's the 3rd number? The 3rd number would be the total students. So you would add those 2 together. 8 plus 16 equals 24 students. Okay, 3 numbers, 1 part, the other part, and the total. Another example, a class of 30 students has 12 girls. What are the 3 numbers in this ratio? So we have 30 students, we have 12 girls, and we need to know, this is where you need to look at this and say, do I know the total? If you know the total, then you have to subtract. Up here we didn't know the total, and so we had to add. So the other number would be 30 minus 12, which is 18. And then can you figure out what the other people would be if they're not girls? They have to be boys. Okay? Sample space. So that was ratios, and now we need to talk about sample space. And sample space is used in probability. Definition that's important that you need to know. Sample space is a list of all the possible outcomes of an event. Remember, probability is favorable outcomes divided by the possible outcomes. So sample space for tossing a number cube. So if you roll a number cube, you could get a 1, a 2, a 3, a 4, a 5, or a 6. And then frequently you'll see the braces in front of it. This is the sample space. This is a list. This is how you need to answer sample space questions. Okay, and we can use this then to know how many outcomes there are for probability. Again, with the sample space, if there's more than one event, make a tree diagram or a table. So the sample space for flipping a coin once and rolling a die or a number cube. Alright, so here's how this works. If I flip a coin once, what are the outcomes that can happen? We're going to use this tree diagram. I can get heads and tails. Okay, that's once. Then I'm going to roll the number cube. So this would be coin and then number cube or die. So from the heads I could get a 1, a 2, a 3, a 4, a 5, or a 6. And from the tails I could do the same thing, a 1, a 2, a 3, a 4, a 5, or a 6. So now this is a tree diagram. This is not the sample space. Okay, we need to take this and write it as a list. So all you do is start at the top branch and go down to the end. So it's going to be heads 1 or heads 2 or heads 3, heads 4, heads 5, and heads 6. So we went from heads down to the end of all of those branches. We're going to repeat that with tails side. So it's T1, T2, T3, etc. Okay. So now we can see the total number of outcomes. There are 12 outcomes. So we're going to find the probability of tails and a number less than 3. So remember, probability was favorable outcomes divided by possible outcomes. So it's a fraction, and we know that possible outcomes are 12. How many of them are tails and a number less than 3? So none of these are all heads, and the only ones that are tails and less than 3 are 1 and 2. So it would be 2 out of 12, which will reduce to 1/6. That's your probability. Okay, now there's a really neat way that you can do those problems quickly for figuring out the possible number of outcomes. It's called the fundamental counting principle, that states if an event can happen a number of ways and another event can happen a number of ways, to find the total ways that they can happen together, multiply the ways of each. Okay, so that's a lot of ways and multiply and trying to figure things out, right? So here's what we're talking about. We just did this. How many ways can a coin flip occur? Okay, you either get heads or tails, right? And on a die roll, you get the numbers 1 through 6, so there are 6 different ways that can happen. So the total ways possible, you multiply those together, you get 2 times 6 equals 12. Okay, so that's a really, if you can remember to do that, that's a really quick way to figure out how many options there are or how many possible outcomes. It does not help you figure out which ones are possible, but it does help double check to make sure that you have all of those options available. Okay, that's it for lesson 36. I hope you have a good day. See you in class.